Everybody, my name is Brandt Sandman. I'm a first-year PhD student at Virginia Tech with the Industrial and Systems Engineering Department, working with the National Security Institute. My boss is Dr. Paul Walk. If you got a chance to be at a session earlier, this is just a more condensed version of that. This is also a project that's been done in conjunction with the University of Arizona with Dr. Joe Gregory and Dr. Alejandro Salado being from there. Everybody else, Jeff Kerr, Tim Sherburne, Tylen Topchu, are all from Virginia Tech. And I'll be talking about Operation Safe Passage today. So the challenge that we face is that it's very difficult to use real programs and real systems when working through our test and evaluation. It can take many years and a huge amount of money to work through the problems in testing and evaluation, and it can cause even more delays, more budget overruns. The key examples that we use are the F-35 and the James Webb Space Telescope, two projects that took an exorbitant amount of money and an exorbitant amount of time to actually complete. To address this challenge, we have come up with a phased digital test and evaluation transformation. We start with the first phase, a phase a lot of us that are still in right now, and this is a document-based approach to testing and evaluation. Next, we move towards a conversion to a dynamic data continuum. We start to digitalize these processes and work towards having something that implements new tools and methods. Phase two, and this is what the focus of this presentation will be, is dynamic testing and evaluation planning and execution, where test phases are not only linked descriptively or quantitatively in terms of resource consumption and schedule and cost planning, but the confidence that they generate in the accomplishment of mission objectives, or the decision dependence, developmental tests informing the operational tests. And then our final phase, this is the endpoint that we still haven't reached yet, but this is the integration of everything into a full digital environment that allows for the interaction and accumulation of past knowledge to inform our future development of systems and the testing of and evaluation of those. So within our digital test and evaluation transformation and the challenge that we face, we propose the use of a proxy, something that we don't have to require a huge system that would take many years or many dollars to actually produce. So this is Operation Safe Passage. I'll go through each of the mappings of the context here, but we start with a realistic mission. This is an unmanned ground vehicle, or a UGV. Yeah, I got that right. An unmanned ground vehicle with a role in some broader military environment, whether it's surveillance or threat detection, threat elimination, being applied to any kind of location, whether it's no matter the climate, no matter the terrain. We map that to something that we call Operation Safe Lego. And this proxy is something that utilizes Legos to conduct the same goals, albeit slightly modified to make it more realistic and to allow more control over this. This is something that is much more small scale, which allows us to change the variables and run our testing more efficiently. We've conducted the testing of the climates within the deserts at University of Arizona and the cold mountains at Virginia Tech. You can see the vehicle in the middle picture is just our little Lego robot using the Mindstorm EV3 kits and the Spike kits. Further mapping of the context, the key performance parameters are mainly shared. This is something that we would like to keep consistent, and the ultimate goal of this unmanned ground vehicle is the guarantee of safe passage through a hostile environment, and that includes the threat detection, threat classification, guaranteeing safety, the battery performance, something that we've been testing for, and threat neutralization or detection. The realistic threat, obviously, for the unmanned ground vehicle is mines or explosives of any kind. My bosses didn't want me playing with explosives, so we had to opt for something better, which was sticky notes. Not that much better, but what we did is use the capabilities of the robot and an optic detector or an optic sensor to map to certain spectrums of color so that we could detect certain sticky notes. Our environment is on the bottom is a much more simplified of the environment that would be implemented across the entire DoD. Like I said, this proxy is developed for better control and better simplification while also being representative of something that might be much, much bigger than it is. So what's happening now with this project? We're currently going through a few different kinds of physical testing and finishing up model development and refining our digital ecosystem. These are some models that were developed in Cameo or Magic Systems, same thing. And they outline the capabilities that are properly mapped to some of our robots. And these kinds of models are something that are currently being integrated into a software called Violet for use on harmonization as well as integration of the other software components of this project to essentially create a comprehensive digital environment. We've got some physical testing going on, and we have physical versions of our robots, something you can see pictures of at the poster session. But to tie it all back together, we go back to that visual you got a glimpse of on that phase 2. We actually start from the right side on this screen. We have multiple different tests, developmental tests that are performed with different levels of confidence. Say we have a test in the cold mountains and one in an urban area done with high confidence, but you have a test done in a desert with very low confidence. This informs our operational test to be conducted in the desert and essentially simplify and inform our future tests so that we can build off of previous work and legacy systems. And what's happening for the future is we want to keep developing the capabilities and assess different use cases and scenarios for this project because threats change and capabilities of this robot can change. And that's something that we would like to show that this is capable of being mapped to and adaptable to multiple different kinds of systems and different problems that really help us practice and inform our tooling and methods. So this concludes my presentation. Are there any questions?
So we do have time for a question.
Hello, Frank from IDA. Thanks for the talk. I was wondering what's the difference between the robots? If you can explain the,
Oh, like within this picture?
yeah, like what's going on.
So this is just, these aren't our specific robots that we used, but this is just to show the different iterations that might be conducted to use the testing and developmental test of an older version while they can still be used as a legacy version to inform our future versions of a robot. This is something that allows us to simplify the process of testing for our iterations of different systems. Because we can take the information from previous versions and inform our future versions.
Cool. I think we might have had one more question.
So again, when you introduced the problem, you talk about the cost and time aspects, and understanding this is a big challenge, but maybe you could help, for me as well as the rest of the audience, just put into context, some of the next steps that would be the steps towards addressing those big time and cost issues in terms of the digital engineering.
Yeah, so our goal is the different use of proxies while also advancing the tooling and methods that went into the digital engineering and test and evaluation here. So in other applications and in future cases, this is something that we wish to kind of speed along the process of test and evaluation, that we can use prior systems or prior iterations that would inform something and increase the process because, like F-35, for example, or the James Webb Space Telescope took years, and that one of the problems was the iterations of those tests. Sorry, I'm trying to wrap this up. We can always talk more at the poster session, but essentially just speeding up the testing process, informing tests so not as many tests may not have to be conducted. I hope that answers the question. We can always talk later more.